Hello, everyone, and welcome to the first video of the first chapter of General Chemistry 1. In this chapter, we're going to be introduced to the study of chemistry. And when we study chemistry, we're going to study matter, what's referred to as the properties of matter, and how matter behaves. So, to define matter, we can say that it is anything that has mass or what you may think of as weight, but we'll differentiate why that's a little different. And it also takes up space. We commonly say that it will have volume. And a property is any characteristic that will allow us to differentiate between different types of matter. So when we classify matter, we can classify it in different ways. We can define it by its physical state, so whether it is a solid, liquid, or gas. We can also talk about matter by its composition. Is it one type of element? Is it a compound that is two or more types of elements? Or is it a mixture of elements, a mixture of elements and compounds, or a mixture of compounds? So first here, let's look at these different physical states, sometimes referred to as phase. First, we have the gas phase, where gas molecules will take the shape of their container. They do not have what we would call a fixed volume that can change, and they can be compressed or can expand. And the molecules are spaced far apart from one another and they move fast. They have lots of energy. And then we move to liquid phase next, and that does have a distinct volume that will not change. But the volume is independent of the container. So when we talked about gases, we said that they would expand or take the shape of their container. The liquid volume can be contained in a container, but it doesn't take its shape. Only the bottom portion, rather. It doesn't expand to fill it. Then we talk about solids, the last phase here, and this has a definite shape and volume. There's no change in shape. Like liquid, when we pour it, it can change its shape, but solid, that will always be the same. So here we see some representations of water vapor here. So these would be in the gas phase, which we can abbreviate like this. And then in the middle, we see liquid molecules, and then finally solid over here. So notice the gas molecules, there's a large space between them, but they still have these two white balls here, which represent hydrogen, and then one red ball in the middle there, which is oxygen. So for water, the chemical formula is H2O, and we can see that in gas phase or water vapor. And then we have in the middle that liquid water. Notice the molecules are now kind of on top of one another, but they can move past one another. They can slide around. And then we have over here on the right the arrangement of solid water, which we call ice. And you can see that now the molecules are arranged in a very ordered pattern, and they are not moving past one another. They are kind of locked into place there. So I've talked about atoms when I said that water has oxygen and then two hydrogen. I was referring to the atoms within the water molecule. These are called the building blocks of matter, and we'll study the periodic table in this semester, and we'll see that all the different elements are arranged in an organized fashion, and different atoms have different elemental symbols. So an element we can say is all the same type of atom. So we can have hydrogen, that's one type of element, oxygen is another, and then there's so many more that we'll see on the periodic table. And then when we represent just a single atom of an element, you'll just see one individual ball here. So helium, for example, is a gas that is a monoatomic form. And then we have in the next box here, we can see two of the same element, so the same color here has combined to form a molecule, but something like hydrogen gas tends to form like this. So we'll see H2, whereas helium, we would just see that one atom. So note that there's different representations of matter shown here. In the third image, we see two different colors. So this is now a compound where we have two different types of atoms formed in a molecule form. And then last but not least, we see over here all the way to the right, a mixture of, we have monoatomic elements, diatomic elements, molecules like H2, and then we have those compounds. So this would imply a mixture. So again, our definition of elements shown down here shows us that they are substances that cannot be broken down into simpler substances. With normal chemical means, there are nuclear reactions which can break them down further, but we will not talk about that this semester. And then it tells you to reference the periodic table here. So that's where you would find the elemental symbols. Then when we start combining two or more elements, we get compounds. And we should note this law here that is important, that the elemental composition of a compound is always the same. So when we're talking about water, for example, that specific compound, it will always be H2O, where we have two hydrogen atoms in a ratio to one oxygen. So that's what makes water, that's what makes a specific compound. And then there's hydrogen peroxide, which is H2O2, which has a 2 hydrogen to 2 oxygen ratio. And again, that's hydrogen peroxide. And this has very different properties. It's a completely different compound than water, although it does contain the same elements. So we can define some other terms here. So a mixture, as you saw above, can be a combination of elements. It can be a combination of elements and compounds or multiple compounds. When we talk about a pure substance, that's when matter has distinct properties and a composition that does not vary. So for example, if we only have water with nothing dissolved in it, that will be a pure substance. These last two terms here, homogeneous and heterogeneous, refer to types of mixtures. So we have a homogeneous mixture, which has the same composition throughout. So that would be something that looks the same. So like if you made iced tea and you mixed up the powder and the water, that tends to be homogeneous. Milk is also a mixture that they have homogenized. So if you ever see that on a gallon of milk, that means that they've made it look consistent throughout, that we don't have a liquidy and then a fat layer, but it looks the same. And then a heterogeneous mixture, this can vary in texture. So beach sand, for example, sometimes we have some organic and then some silicon dioxide in there, some grains of little broken down rock. So we can vary in texture and composition. So that means that one sample of sand may look different than another sample of sand on the same beach. So we have this flow chart here that will end with this chapter, or this section rather. So we see that matter can be, we can ask ourselves this first question: is it uniform throughout? And then we can follow this along, and if no is the answer, it's probably a heterogeneous mixture. But then we could say yes, and we can say, okay, well, it's homogeneous. Does it vary in composition? If no, it's a pure substance. If yes, then it could be a homogeneous mixture. Then we go down to the pure substance block here, and we can say, is it separated, or can it be separated into simpler substances? So if no, then we're already a pure substance that is an element. But if we say yes, then if it's broken down into its elements, then it was probably a compound. So this sample exercise here, we'll think about white gold. And it contains gold and then a white metal, such as palladium, which kind of dilutes the gold in a sense in this solid mixture here. And we know that two samples of gold differ in the relative amounts of gold and palladium that they contain. So we're told that they differ in the amounts. Um, and we're told that the samples are uniform composition throughout. So we want to figure out using this flow chart here, what is white gold? So we're told here that, we'll assume that it's matter. We know that it's uniform throughout because we're told that. So we're going to follow this direction over here. And then does it have a variable composition? Well, we're told yes to that as well. So we have relative amounts. That means that it's variable composition, but uniform throughout means that it looks the same. So we have a homogeneous and we'll say a mixture. So we can have solutions. Generally, we think of liquid-liquid solutions, mixtures of two liquids or a liquid with a solid dissolved, but we can also have solid or gas solutions as well. So we'll keep that in mind as we continue further this chapter.